Students, thank you for being here and watching my latest installment video on Special Topics 2, which is a systematic review of Chapters 6 through 8 from last semester of General Chemistry. In this one, I'm going to remind you how to draw Lewis structures. Are you ready? Let's go ahead and begin. The formation of covalent bonds can be represented using Lewis symbols. For example, the formation of H2, which is a molecule of hydrogen, from two individual hydrogen atoms can be represented like this. If I have two individual hydrogen atoms, each with its individual single valence electron, when they go together, they basically snap those two electrons into each other's holes in a complementary fashion to form this molecule. This is H2, or a Lewis diagram of H2. So in forming the covalent bond, this bond between these two hydrogen atoms, each hydrogen atom acquires a second electron from its partner, which makes each hydrogen atom feel as if it's achieving the stable noble gas configuration of helium. On that note, forming a covalent bond between two chlorine atoms gives a similar chlorine or Cl2 molecule and can be represented in this way. I've got each of the individual chlorine atoms that have Lewis symbols showing 7 valence electrons. When they get together, each of these unpaired electrons snaps into each other's complementary hole to form these two chlorines that are now bonded together. This is a Lewis representation of chlorine gas, or Cl2. So, by having each individual chlorine atom share its unbonded electron and then plugging them into each other's empty holes, each individual chlorine atom now feels as if it has 8 electrons around it. That is a full octet in its valence shell, thereby achieving the noble gas configuration of its nearest neighbor, argon. With this groundwork laid, I now want to teach you how to draw Lewis structures. Lewis structures are small, simplified models or depictions showing the shapes of individual molecules. To draw a Lewis structure for a molecule, we first of all have to add up all the valence electrons for every atom in the molecule. For anions, add 1 electron to the total number for each negative charge. For cations, subtract 1 electron from the total number for each positive charge. Don't worry about which electrons came from which atoms, only worry about the total number. Step 2, write the symbols for all the atoms in the molecule showing which atoms are attached to which. Then connect them with a single bond, which is a dash, which represents 2 electrons. Chemical formulas are often written in the order in which the atoms are connected. In many polyatomic ions, for instance, the first atom in the formula is the central atom in the Lewis structure. Usually, but not always, the central atom is the less electronegative atom. Step 3, complete the octets around all the atoms bonded to the central atom, except for hydrogen, which only wants 2 electrons around it. That is, hydrogen only wants a 2-tet, like helium. 4, place leftover electrons on the central atom, even if doing so results in more than an octet of electrons around it. And 5, if there are not enough electrons to give the central atom an octet, try multiple bonds, such as double or triple bonds. That takes us to some wonderful lecture questions, beginning with this one. Please construct a Lewis structure for O2 in which each atom achieves an octet of electrons, and then explain why it's necessary to form a double bond in the Lewis structure of O2. Separately, draw Lewis structures for the following molecules. Now, I'm not going to answer these questions for you here, but we'll post a link to a separate video that you're welcome to watch if you'd like, in which I address some of these, and you can hopefully use it as a guide. Here is another question. The Lewis structure of the carbonate ion is which of the following? Once again, I'm not going to answer this for you here, but invite you to attempt it on your own. And this last one, the Lewis structure of N2H2 shows what? In order to be able to answer this question, you have to draw the Lewis structure. And you have to do it correctly. I'll let you do that on your own. Here's another. The Lewis structure of phosphorus trifluoride shows that the central phosphorus atom has blank non-bonding and blank bonding electron pairs. Please keep in mind that when it's talking about non-bonding, that is the same thing as saying lone pairs. And the number of bonding pairs is the number of lines that are connecting that central phosphorus atom to the fluorines around it. Now, I'm not going to do this for you, but we'll invite you once again to do it on your own. That takes us to the end of this video and the end of this lecture set. Please stay tuned to the next one, in which I'll continue my Special Topic 2 systematic review of Chapter 6 through 8. Until next time, my wonderful students, have an enjoyable rest of your day.